In the first step of the citric acid cycle, acetyl-CoA donates the acetyl group to oxaloacetic acid to make citric acid. The high-energy bond between the acetyl group and coenzyme A makes the addition of the acetyl group to oxaloacetic acid possible. In the second step of the Krebs cycle, citric acid is rearranged to form isocitric acid. During this reaction, water is removed from one carbon atom of citric acid and then added back to the adjacent carbon atom. This rearrangement is necessary to prepare the molecule for two consecutive decarboxylation steps, both of which will generate usable energy. In the third step of the Krebs cycle, the isocitric acid is oxidized and decarboxylated to produce alpha-ketogluteric acid. The free energy released during this step is used to reduce an NAD molecule to generate an NADH molecule. The NADH molecule can move on to generate 3 ATPs through oxidative phosphorylation. In the fourth step of the Krebs cycle, alpha-ketogluteric acid loses another carbon atom in the form of carbon dioxide. Since the loss of a carbon dioxide molecule is accompanied by a large release of energy, another NADH molecule is generated from NAD, and the remaining 4-carbon succinyl group is attached to coenzyme A, producing succinyl-CoA. This coupling step allows even more energy to be extracted from the succinyl molecule. In the fifth step of the Krebs cycle, water reacts with succinyl-CoA, releasing coenzyme A and producing succinic acid. Breaking the high-energy bond between the succinyl group and CoA releases a large amount of energy, which is coupled to the phosphorylation of a guanosine diphosphate molecule to produce guanosine triphosphate. The GTP carries the same amount of energy as an ATP molecule, so it can be used to produce an ATP molecule. The coenzyme A can be recycled back to the previous step to react with alpha-ketogluteric acid. The sixth step of the Krebs cycle involves another oxidation reaction, in which succinic acid loses 2 hydrogen atoms to form fumaric acid. FAD gains these 2 hydrogen atoms, reducing FAD to FADH2. The FADH2 molecule has the reducing capability to produce 2 ATP molecules in the oxidative phosphorylation process. In the seventh step of the Krebs cycle, the newly created double bond of fumaric acid is hydrated to form malic acid. This step does not produce any energy in itself, but it prepares the intermediate for the next step, which is an oxidation step that will produce energy. In the eighth and final step of the Krebs cycle, a full cycle is reached. Malic acid is oxidized to regenerate oxaloacetic acid, one of the reactants for the first step of the Krebs cycle. At the same time, a molecule of NAD is reduced to NADH.